In this lesson, we will dive into what reversible reactions are, what dynamic equilibrium means, and why this idea is so important in chemistry. By the end, you will see how this knowledge is the foundation for predicting and optimizing reactions in both the lab and industry. What are reversible reactions? Not all chemical reactions go to completion. Some reactions can proceed in both the forward and reverse directions. In a reversible reaction, the products can react to reform the reactants. We represent reversible reactions with a double arrow. Example: when nitrogen gas reacts with hydrogen gas to form ammonia, ammonia can decompose back into nitrogen and hydrogen. What is dynamic equilibrium? When a reversible reaction occurs in a closed system, it will eventually reach a point where the rate of the forward reaction equals the rate of the reverse reaction. The concentrations of reactants and products remain constant over time, but not necessarily equal. This state is called dynamic equilibrium. It's called dynamic because both reactions are still occurring but at equal rates. It's equilibrium because the overall composition of the system is stable. What dynamic equilibrium is not? It's not when all reactions stop. It's not when the amounts of reactants and products are equal. It is when the rates of the forward and reverse processes are equal, resulting in constant concentrations. Conditions for equilibrium must occur in a closed system. No matter enters or leaves. Temperature and pressure must remain constant for gas phase reactions. Time is needed. Equilibrium is reached after the rates adjust and stabilize. Dynamic equilibrium is the foundation for understanding how chemical systems respond to changes. It sets the stage for Le Chatelier's principle, equilibrium constant expressions, reaction quotient and predicting direction, solubility equilibria. Understanding equilibrium helps chemists predict how to optimize reaction conditions in everything from pharmaceuticals to industrial synthesis. Key takeaways: a reversible reaction can proceed in both directions, from reactants to products and from products to reactants. At dynamic equilibrium, the rate of the forward reaction equals the rate of the reverse reaction. Concentrations remain constant over time. Equilibrium is dynamic, not static. It occurs in a closed system and requires time to be established. In the next lesson, we will explore how to write equilibrium constant expressions using concentrations of reactants and products, and how these expressions give us insight into the position of equilibrium. Let's keep going.